We've now created an inheritance hierarchy using abstract and extends. You don't have to use abstract, but you will for the first assignment. And extends. Seeing a little bit about how to use super to get there. So let's talk about working with these extended objects now, a little bit more detail. So one of the things about inheritance you have to be aware of is in constructors. A constructor is a way of you as the class designer, the author, the code writer, to say, anytime you create an instance of my class, I must have this information to be useful. So think of it this way. If you're going to be a coder, in order for you to be useful as a coder, you have to have a computer. You can't walk into a new job. And let me tell you, I've had this happen before. I was a consultant being paid an obscene amount of money, walked into the job, and didn't have a computer there for me to work on. It took them almost 2 weeks to get a computer for me to work on. Kind of hard to do my job when I don't have a computer. There's not much I can do. And so we got to say, hey, in order for me to do my job, I have to have a computer. And in the programming world, I can ensure that. I can guarantee that by using constructors. And so the same thing is true for abstract classes. In the abstract class product, to be a product, I have to have a price. If I don't have a price, what's the point of being a product? You can't buy something without a price. And then it's just something you give away for free, and then that's not interesting as a product anymore. So I can enforce the fact that all abstract classes that are products have a price by putting that constructor instead of there. Which means that every child class of a product, everything who claims to be a product, must give me a price. The food class must also obtain a price. Now, the most common way this is done is for the food product to also ask for a price. So we can see up here, product double price, food double price down below. This is a constructor for product. It matches the class name. This is a constructor for food. It matches the class name. The implementation down here then, if I don't need to do anything else differently, the first line must be satisfying the constructor up above. So think of it this way. If you're building a building, I have to build a foundation, I have to build the first floor, I have to build the second floor. As much as we're drawing this picture backwards, if I want to be a food product, I must have a solid foundation of being a product first. I must build the foundation before I can build the first floor. So even though we draw it top to bottom, in this analogy we're going bottom up. So in order to be a food, I must first be a product, and thus I have to take the price and hand it to the product and get the product set up. Because in order to be the food, like maybe the first thing I do for food is say I'm going to give a discount on all food things. Drop the price by 10%. Well, if I haven't established the price, then how do I set up that price? So the first line must be a call to this constructor. I could say price divided by 2. I'm getting that passed in, but I can't do other operations before I do this first line as part of this. Just a little bit of a coding requirement. We'll see this when we get into coding examples. We'll see what happens if we don't do this. So past that, very simple in concept. When we get to code, we'll see. It can be complex. There's a lot of errors that can pop up from that. But once I get past that, once I have my constructor created, all things are created the same. But there's certain rules that you must follow. Because remember, one of the rules of abstract classes is I can't use them. I can't work with them. Go get me a car. You can't go get me a car. You have to get me something more specific, something more specialized, not generalized. Same thing's true here. Go get me a product. Well, I can't get a product. I need to get something specific. Now, specific is a concrete class. If it's an abstract class, you can't build an instance of it. A concrete class, you can. So, that being said, will the first line of code work? Product is equal to new product. Well, now that first line isn't going to work because I can't build new instance of a new product. The second line of, it's going to work. Food, breakfast equal new food. Is that going to be okay? Absolutely. It's just a class. I don't care the fact that it inherits from something. At this level, once we start using the class, it's just a normal class. The fact that it inherits from something is out of our range of caring. Product lunch is equal to new food. Does this work? Well, am I allowed to create a variable of an abstract class? Absolutely you can. Yes, you can create a variable to point to that. It's a grouping. Can you point to a car? Yes, I can create a car lot. It doesn't matter what brand it is. I can park cars. If I do valet parking, I can park any car. 4 wheels, Key, not even that. Push button, I can figure it out. I know how to drive those things. So I can point to any food product, in this case, new food. So can dinner food is equal to lunch? That's an interesting question. I know, looking at this line of code here, that lunch is equal to new food. But lunch of a variable is equal to a product. So can I take food and assign it to a value that is stored in a product? Well, no, I can't. So the first line of code doesn't work. That product is abstract, like I said. The last line of code doesn't work because dinner is looking for explicitly food. Product, lunch, even though I assigned it lunch last time, something could have happened along the way. Or I could change my code. Product could point to a puppy. I don't want to eat my puppy for dinner. I could point to a 2x4. Certainly don't want to eat a 2x4 for dinner. So you got to remember that the left-hand side determines the type of the variable. The right-hand side is just what's going to be assigned. I can always take something that's a subclass. If that term is anything that extends out another class is called a subclass. So I can take anything that extends it and assign it to a variable of the higher level thing. But I can't do it the other way around on its own. I have to know, is this actually a type of food? And there's some ways I can go through and check that, but I can't just do it automatically. So we'll come back to that more as we go. But one little hint I want to bring to you as you're doing your work. This work all gets us the class being built. But notice this little method right here. So everything we did up above here, we created a class, we extended the class out, that's fine. But notice I have to have some code to drive this. So as you're doing your homework this week, don't forget you need to build code like we just saw. And we'll see this, we'll build it some in demo, don't you worry. You have to have some code that's an entry point. You have some code that's going to build the objects for you. This inheritance stuff is just building a structure. I can build the opportunity of building classes that create this stuff, but I need to also build objects to really understand the stuff and also to have code that runs. So just remember that as we're going forward and we're getting to the examples, that you're not going to just build the classes. You have to have something that drives them, something that makes it go forward.